Alright, moving on, we're going to take a look at several other types of functions, starting with the squaring function, y equals x squared. That is a parabola. A couple different things in here just to note the domain. What x's can we use? We can use any x, so our domain is all real numbers. The range is everything above 0. Notice how this is our cutoff and we're only going up from there, so for our range y is going to be greater than or equal to 0. For this function, the function is even. We have symmetry on the y-axis. If we folded this over, we'd have the exact same shape. It has an intercept at the origin at 0, 0, and it's decreasing from negative infinity all the way down to 0, and then it turns around and it increases all the way to positive infinity. We've already said it's symmetric with the respect to the y-axis. That's the same as saying even, and the graph has a relative minimum at its intercept of 0, 0. Cube function is very similar, except instead of x squared, we are talking about x cubed. It's going to start low at negative infinity and take off and go to positive infinity. We can plug in any x number we want and we will get out every possible y number if we plug in the proper x number. So domain and range, all real numbers. The function is symmetric with respect to the origin. If we flip this over and rotate it at 180 degrees, we would have the exact same thing, which means it's odd. We have an intercept at 0, 0. And it's increasing over the entire graph. It's always going up. Square root function, y equals the square root of x. Domain, all positive numbers and 0. Range, all positive numbers and 0. Other way to say that is non-negative. So y has to be greater than or equal to 0. That would be our range. Our domain, x has to be greater than or equal to 0. We do have an intercept at 0, 0, and we're increasing starting at 0 and going all the way to positive infinity. The reciprocal function, something that you've probably been shown before but haven't seen in a while, f of x equals 1 over x, is going to look like this graph here with a asymptote. It will not cross the x or the y axes. So the domain of the function is negative infinity to 0, and then this thing right here is saying and 0 to infinity. So x can be anything you want except for 0. Y, same thing, it can be anything you want except y cannot equal 0. The function is symmetric with respect to the origin, so it's an odd function. It does not cross any axes, so it does not have any intercepts, and we're decreasing over the entire thing. We're going down and we're going down in the vertical axis. Alright, something might be new for you, step functions. So what this is saying, this graph here, is whatever the x is, if the x is, and we're talking about decimals on this one, if the x is 0.75, something like that, then we're just going to truncate it, cut it off, and say that y equals 0. So if you'll notice on the graph, everything leading up, everything smaller than 1 and bigger than 0, we just turn into y equals 0. If x equals 1.1 or 1.2 or 1.5, so here x is 1.1, 1.2, 1.5, any of those points, we just cut off the decimal to figure out the y value. So y equals 1 for all of those. As soon as we hit 2, we jump up to 2 over here. And we don't care about decimals, decimals, decimals. As soon as we hit 3, we jump up to 3, decimals, decimals, decimals. The way we write this is the double bracket of x, and that's your step function. All right, it's the greatest integer, smaller than the decimal. Let's go ahead and try one of these. Let's evaluate the function when x is -1, 2, and positive 3 halves for the step function plus 1. So let's go ahead and do the step function of -1 on these. Alright, so the important thing to remember here is that this is really only affecting decimals. If there's no decimals, then it's just the 1. And we add 1 and we get 0. So the f of, if we plug in -1, equals 0. If we plug in 2, are there any decimals that we have to worry about here? No. So it's not going to affect it at all. F of 2 equals 2 plus 1. F of 2 equals 3. Now 3 halves is really the one that's going to be affected. So we have f of, I'm going to turn this into a decimal, 1.5 equals, what do we plug in for x? We plug in 1.5 plus 1. Now the step function, we take our decimal, get rid of it. So we're just going to be left with 1 plus 1. So the function of 1.5 equals 2. Go ahead and try problem 43 on your own and see if you can make this work. Pause my video, press play when you're ready to go. Alright, if you're ready to go, let's go ahead and take a look. This is just the straight step function. We're crossing off decimals, so the f of 2.1 equals 2. This also equals 2. This equals, now here's a trick, the function of negatives. If we're thinking about the negative, we want the integer below this. Okay, so -3.1, this is going to turn into -4. If we thought about this as far as the number line, 0, 1, 2, 3. These first examples, 2.9, we're always just going back to the last integer. 2.1, we're going back. If we go back here to -3, -3.1's right there, same rule applies. We have to go backwards to the last integer. So negatives are a bit of a trick on here. Be careful with them. 7 over 2 is the same as f of 3.5, and so 3.5 is going to go down to just 3.